submit their assignment. Okay, this is for learning for you all. Okay, so today we are starting where we left yesterday. So I'm just sharing. So yesterday we discussed about some started with the plottings. Okay, so plotting is one of the important thing for the today's era, as we are all of you, some of you are doing research at MTech level and PhD level. Okay, so plotting with MATLAB is very easy and very interesting, and you can add it according to your need. Okay, so as you can see, we can plot x of our desired. This is a len space 0 to 4 pi, means 0 to 4 pi will be the limit with a it was not audible. Huh? Now only. Sir, it is audible. Please. Now you talk. Hello.
Now it is audible, sir.
Okay.
Yes, sir,
Okay.
it is audible, sir.
Okay. Thank you. Thank you. Sorry, I'm starting again. Okay. So I'm talking. Sorry for the disturbance. So we are talking about the planning and how we can show our data in a better way. Okay. As of now, we all are doing research. Okay. So for research purpose, MATLAB plotting and these figures are very important. Okay. So this is showing for the 1000 data points between 0 to 4 pi, and this is showing 100 data points between 0 to 4 pi. Again, I'm showing you the previous one, which is, so you can see the edges over here. Okay, so less data points are here, so smoothness is decreased. Okay, as I increase the data points, so smoothness will be increased. So as you can see, this is for 10 data points, this is for 100 data points, and this is for 1000 data points. Okay, so according to our need, we can change it. Okay, so next next we are moving ahead. So this figure you can see, these are 10x value, these are 1000 values. Okay, so if you plot with the with with the not same size data points, so we will get error. Okay, if you plot one this matrix which is having dimensions 1, 2, and this is having 1, 3, so it will show an error. So dimensions must be equal for what you are plotting in x and y matrix. Okay, so you can exercise some plotting commands. Okay, so let's talk about yesterday also we talk about some functions, so we can recap. Okay, the function that exactly looks like the AND scripts, only one difference is there. What the difference is, the function must have function declaration. Okay, function can be called anywhere in any M file. Okay, and so you can see here the help files. Okay, so what you need, what we need, input argument for any functions and output arguments. Okay, if some function declaration is there, so it will take x as input and it will give you what you want, average, mean, standard deviation and range as output. Okay, so it will not ask any data set or points. Okay, it simply need a input and it will give you output. It can be used in any M file. So as we can elaborate, this one function name should be unique. Okay, it may have multiple inputs, input 1, input 2. The function name should be match in M file. Where you are calling this function in the M file, the function name should be exact. Okay, and the output that you are using in M file, it should be the name of x, comma y, comma z as you are using in this function must have the reserved word in function. If more than one output must be in bracket, it must be shown in bracket. So no need for return. Okay, MATLAB returns the variable whose names match those in function declaration. So you can use return to break and go back to invoking function. What is the scope of the variable? You can use as global variable, local variable. So how we can overload the functions? So now we are familiar with the yesterday also discussed the zeros. If you give just zeros into the dimension, it will give you matrix of zeros, size of matrix, length of matrix, sum of matrix in one command. Okay, so you can see the attribute of any documentation. If you want to need, just type help and the variable size zeros or anything you want to know about. If it is available in MATLAB, it will return you with doc file and you can click on and you can explore that one. Okay, so help file, it describes several ways to invoke the function d equal to size of x, mn in the bracket size. Okay, it will give you the different information about that function. But function are generally overloaded. So overloaded means it can take a variable number of inputs and it can return also a number of variables in output. Okay, so what would the following command return? Just you can do the exercise a zeros 2 comma 4 comma 8. Okay, so n dimensions matrix are okay. D size a, it will show you the size of the a matrix. Okay, in bracket m comma m is a matrix is there, it will show you the size of a. XYZ, its dimension is there, it will show you the size of this matrix. So you can overload your own functions by having variable number of input and output arguments. So you can see in help toolbar of the MATLAB, v arg in means variable argument input. Okay, Hello. 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 Okay. So you can type very variable help p org in. Okay, so it will show you the details about this function. Okay, so the input must be as it is available in the document. Okay, so this all must be in lowercase. If any v is capital, so it will not show. It will show it is not available in MATLAB library. Okay, so as all the inputs and output argument, you can check. Okay, so there are many scope of MATLAB, so it is not possible to cover all the things over here. Okay, next function exercise, you can plot this function, plot as in f1. Okay, you can plot the sine wave with frequency f1 on the interval 0 to 2 pi. Okay, sine is fx. To get good sampling, use 16 points per period. Okay, so this is plot is showing 16 points per period. Hello, I'm audible. Hello,
Yes,
hello.
sir. Yes, sir. Yes,
Okay.
sir, you're audible.
Yeah, I don't know, but someone muted all the participants. I asked our admin also, Naveen sir, he's telling he not muted anyone. So please don't disturb if anyone is doing like that. I request to be patient on this session. Okay. So if loop, else loop, and if else loop can be used as it is very common to in all the languages which we generally use. Okay. So if in if loop, this is very basic. Only one command and one condition is there. You can use over here. Okay, if condition is there and command is there, and it can end over here. Okay, else loop means you want to change your first command and want to validate with second one. Okay, so two commands can be used at a one time. So condition must first condition will be there, command one will be there, and command two will be there. In case of if else loop, condition one and condition two condition will be there, and more than two commands will be possible over here. Okay, so no common blocks are between reserved between these words, and no parenthesis is required. So I'm showing all these three in one code. Okay, so here is the one small program where it is showing x equal to 3, a equal to 2, and b equal to 7. So if if we are seeing this if else loop, so if is there x, if b is greater than, sorry, x is greater than b, so it will show you x equal to b. Only one command is there and one condition is there. Okay, so it will be end over here. If this if loop will end over after this one. It will, if I end over here, it will show x equal to b. If I use if else loop, then another condition will be there, x is less than a. So it will return me, there will be a second command, it will return me, it may be anything whatever we want, a square. Okay, it will return me the a square. But in this case, we are using if else loop, if, else if and else. So what will come? X equal to x to the power 3. So if I run this one, so I will get this answer, x to the power 3 means answer will be 27. Okay, so I hope you understand by this small example. Okay, if lots of if else loop are used, these are considered as switch. Okay, so these are small programming we can also incorporate in our research purpose. For loop is there. Okay, for loop is very commonly used for the iterations, known for the number of iterations. So loop variable will be there at what limit you want, 1 to 100, 1 to 10, 1 to 1000, and command will be there. Okay, the loop variable, it is defined as the vector. It will be a vector. It is a scalar within the command block, does not have consecutive values. Okay, for between anything between for line and the end. Okay, so there will be start at for at and it will end at the end point. So some small program is there that also I am showing you. That looks okay. Simply x is starting, x is a matrix from 1 to 5. Okay, if I'm running this one, so x will go from 1 to 5. It will be a matrix of 1 to 5. It have 5 elements. I want a sum of these values. Okay, from 1 to 5. So my condition and my expression will be here. Sum will be sum plus x is function of k. K will be go from 1 to length of x. Length of x will be 5. These commands already we use, length, 0, sum, all we used in previous sessions also. And you can explore more about this. So 1 to 5 will go and it will come over here and all the things one by one. So 1 plus 2 plus 3 plus 4 and it will return as 15 as the answer. So this is the simplest for loop I am showing you. Okay, so if else loop, for loop, like that you can use while loop also. Example also there, and while is there, condition is there, one command is there. If it's satisfying this condition, and it will return you the value. Okay, so for loop, if else loop, while loop is there. You can exercise these loops with your ease with exercises. Now line plots. Now how I can beautify my plots. Okay, so as I shown you in the previous one, that number of data points will increase the smoothness of the plots. Okay, so here you can see you can change the color with the k. Okay, k is the color is there, so it will show you, suppose black color. You can change M for magenta, B for blue, okay, G for green. M will show you the marker type. It is showing the dot connected lot. Okay, and the third one is the line style. How I can change line. Suppose it's showing them dash, or I want to use some star, or I want to use some round circle. So you can change this according to our need. Okay, you can plot without connecting the dots by omitting the line style or one. So we can change this one also. If we don't want a line style, we can remove this one. Only we can show the this dots, so dot will be connected. Okay, so if default we will show, it may be a default dot only, because to show the plot, there's something must be there which is connecting to dots. Okay, for more plots information, you can go to the help plot for full list of color markers and line styles available over here. So you can see your figures, whatever changes you want. Okay, you select the line you can just click on the line and delete or change the properties of that line. Okay, you can zoom in, zoom out the figures. Okay, you can slide the plot around in this space available. You can change color, you can change line width, you can change line style, solid dash, dot dash. Okay, you can change marker, you can change marker size. Okay, 0.5 or whatever limit is there, you can increase the limit also. For more properties, you can click on this more properties, and you want to know the code of this figure, it will also be available, show and code. So by this playing with plot, so the top is the heading we are showing it, playing with the plot. If you play with the plot, you can change it accordingly. For 3D plot, you can rotate it with 3D. This rotator is there, you can rotate it. Save is there, you can save it. Okay. For any edit person, you can click on this one. It will show you a edit bar also. Next, moving ahead. For everything on a line can be customized. Okay. So either you can change on the figure itself, or by the command also you can change. Okay. So you can see over here, plot x comma y will be there. These are the vectors x and y, and x dash dash will be the style of the your plot. Line width you can change, line width to color you can change, marker age, marker face, marker size. Okay. So k, g, these are the some RGB values are signed here. Values are predefined colors, and like G and K, etc. Okay. Doc line properties are the full list of property that can be specified. As you can see, this figure is showing this square face with red dotted line, but this main face color is green. The face color is green. Age color is K. Okay. Marker size is 10. So we can change according to our need. Next, moving ahead, Cartesian plots also available over here. Okay. So we have already seen the plot functions. So we can use this x equal to minus pi with the increment of pi by 100 to pi. Okay, minus pi to pi with the increment of pi by 100. Okay, so you can plot this x comma y with k dash. So it is showing black line with dash. Okay, as the increment at every point it's showing dash. Okay, the same thing syntax applies for semi-log and log-log plots also. You can change these x, y, semi-log x, comma y, k, semi-log y, semi-log y, comma y, r, log-log plots. For examples also shown over here. Next, 3D plots. For 3D plots, we use the command plot3. For this purpose, we need what? We need three vectors, x, y, and z. Okay. So what is x? X we are taking here. Suppose you find some values. Time equal to 0 with an increment of 0.01 up to 4 into 5. Okay. So 3.14 into pi with the increment of 0.01, where x is sine, the value will which is coming over here will come here. Y is cos time, that is this time. Okay. So if we just type plot 3, we are going for plot 3. This one is over here. I am written here. So 0 to with an increment of 0.01 up to 4 pi. X is sine time, V is cos time. Okay, that is time plot 3. If I am running this one, it is showing me this type of figure. Okay, this type of figure it is showing. Now, as I shown you in that the previous slide, you can rotate this one according to your need. Okay, so only for the one axis, this is this label is assigned, so it is showing time over here. You can accordingly assign for x-axis and y-axis also. Zoom in is also there. Solid zoom in, zoom out functional also. Maybe it is not working over here. it may work. Slider is there, so you can slide over in this figure if you want to see this one, and rotate is there. As you see, rotation is there. Okay, so many customization also possible over here. Okay, in this MATLAB, you want to edit copy figure, you can just click on copy figure and paste in Word file. Okay, clear figure will remove this figure from here. Clear command window here. From here also you can clear command window, command is T, and clear workspace. For other properties, you can go to figure properties, access properties, current object properties, and color maps. Okay, you can insert customization also possible. Your view is there, camera toolbar, plot, edit, property. Okay, then insert X label, Y label, Z label manually also possible over here. Okay, it will ask you to edit the, so cursor is coming over, you can edit this one, X label, sign off, time, like that, Y label, cos of time. So you can also edit the figure over here. Okay, so this is about the plot 3 for three-dimensional plotting. If possible, you can do hands-on with me, because all the things I already done. So you can also participate, may also practice with along with the session also. Okay, otherwise I will send you the practice sheet at the end of this session. Okay, so use tool on figure to rotate it. So as I shown you, this output can be rotated. You can define the X limit, Y limit, and Z limit. Okay, so axis mode, how many types of mode are possible? See dock axis. Okay, for more modes. Okay, so axis square is possible. Make the current axis looks like a square box. Means it may be default rectangular, so you can make it a square. Is axis tight? If you type right axis tight, fits access to the data. What is the minimum and maximum limit available for X and Y vectors? It will fit according to the data. Axis equal makes X and Y scales are same. XY, put the origin in the lower left corner, default for all the plots. Okay. Axis IJ puts the origin in the upper left corner, default matrix and images. Okay, for multiple plots in one figure. Suppose I want to merge some figures, more than two figures, three figure, and four figures are possible. Okay, so it can be used by the subplotting. So you can see over here the command subplot 2, 3. The 2 is showing for the rows and 3 is showing for the columns. So 2, 3 means 2 into 3, 6 figures are possible over here. Okay, and 1 is showing the position of this figure. Okay, so in subplot 2, 3, 2 are the rows, 3 are the columns. So 6 figures are possible, and place of this figure will be first. Okay, so make the figure with 2 rows and 3 columns of axis, and activate the first axis for plotting. This first axis for plotting. Each axis can have legend, labels, and title. Different labels and legends are possible for each subplot. Okay, for this one, 2, 3, 4 to 6 activates the range of axes and fuses them into one. Okay, so their axis will be one, and they will show in one axis only. Okay, to close figure, if you want, I want to close first row, third column figure. So just I will type close 1, 1 in matrix 1 and 3. So this figure will be closed, and close all will close all the figures. So I'm showing with an example for better illustration. Is not sub see, just wait. Okay, it's over here. Sir, sir, one call is coming. Hold on, just call. Just okay. So this is one example I have taken. So you can see the subplot. Okay, axis 1 subplot 2 to 1. Okay, subplot 2 to 2 means it is showing 2 comma 2. Second, 2 rows and 2 columns are there, and it will be placed at first place. Okay, 2 comma 2 will be there, and it will be placed at second place. Okay, so 2 to the 4, 4 will be the maximum in this case. This will be the first position. This is the second position. This will be the fourth position. Will be the fourth position. Okay, so I'm writing this one. So x, y1, y2, y3. So you can see all the 4 figures with the help of this subplot are came here. This is the subplot 2 to 1, subplot 2 to 2. Then this is subplot 2 to 3. This is subplot 2 to 4. Okay, 1, 2, 3, 4 like this. These are position. Okay, so this is also possible in the MATLAB, the subplotting. Next, we are moving ahead. Copy and paste figure. I have shown in the first figure. We can just copy the figure, okay, and paste it to the Word and crop it according to our need. We can resize also it. We can also edit it. Okay. So when we are saving the figure, it will show us the different figure formats. Okay, figure can be saved in many formats. Figure can be saved in many formats. The common ones are .fig, .bmp, .bps, .pdf. Okay, so all the figure options will be shown over here when you click on the save as the figure. Okay, so in advanced plotting, you can do the exercise how we can change the line width, how we can change the marker phase, how we can subplot. Okay, how we can squares, how we can reduce the side, how we can test red line thickness can be changed. Okay, now images and surface plots. Okay, so as you can see, visualization of matrix. So matrix are very big in size, so it is not possible to sometimes to better illustration of these figures in x comma y or x comma y comma z. Okay, so sometimes this visualization of matrix will be possible, which this image sc, this command image sc can be used for this visualization purpose. I'm showing you image sc, this one. Okay, so we have 1 to 10,000 data points in between in this matrix. Okay, so 1 to 10,000 comma 100. Okay, so just type image sc and this matrix. This will be full matrix and it will give you this kind of figure. Okay, so you can change this color map. Okay, and if you want to edit this one, you can go to this one, edit, and you can change the color maps also. Okay, this is the color map editor. Okay, so as I told you, insert X label, Y label, colors, all the things are possible over here. So this is the simple illustration of the color map and image scatter. Okay, so color balls also available in this one. Okay, next one is this is color map will open, so you can change the color which is coming, the spirula, Z, hot, cool. Okay, gray, green, you can change according to your need. Okay, so for more help, you can just type help hot for the number of lists available for this colors. Okay, next surface plots. Surface plots are also possible. For this one, built-in function mesh grid is there. Okay, first you have to convert it to the mesh grid, then surface plots. Okay, so surf we are doing already. I made this one mesh grid. this one. Okay, so x is between -pi to pi with the increment of 0.1. Y is also kept same. So x y will be the matrix of this mesh grid made by this x and y. Okay, and z will comprise of these two. Z will be the sin x into into cos y. Okay, just I'm commenting on this one. So many of you know, if I comment on this one, this green bulb will not be appear as the part of the program. Okay, so just clicking on this one, you can see the surface plot. Okay, so this is a three-dimensional surface plot made by simple x and y matrix and mesh grids also. So you can see the grid lines are appearing in this one, and surface of this uh, figure also available over here. If you see this one face only, it will be a two-dimensional, but it is three-dimensional. It is also very important for the representation of the figures. Okay, so this is the mass sharp, and after that you can, I will uncomment in this one, and if I type this contour xyz, so I will get contour of this same data points. Okay, so you can see the mesh grids and contours are available in this figure. Okay, so many plotting possibilities are there. Surface, meshing, mesh grids are there. Okay, so for more explanation, you can just try to surf membrane also. Okay, and this is mesh grid in sharp. Okay, so different shading can also be used. Okay, as shaded, interp, flat, and gray scale. Okay, this can be changed with the help of gray scale also. Next one, I already shown you this one for the same data points. Okay, so it is showing the contour of this one. Again, if you will type hold on mesh xyz, it will show you this figure. Okay, meshed 3D plots. Okay, this will be the exercise for you. I will share at the end of the session. Okay, for 3D plots, 2D and 3D plot, I will share at the end. And this is plots in generate this kind of figures. Okay, specified polar plotting functions also available over here. Okay, so polar, to make polar plots. Okay, what are polar plots mean? It will show a rotation, means you can see 0 with an increment of 0.01 to 2 pi. Okay, comma cos 0 with the increment, same increment into cos. So how it will look like, we will also see. Polar ball, quicker, stairs, fill. Okay, these are some specialized plotting functions. So we will go to this one. Okay, so this is the first one. Okay, I'm showing you one by one. Polar. So what polar will do? Polar will polarize between x and y. So you can see the limits of this polar. It is between 0 to 2 pi, means 0 to 360, 0, and it will end over here, and it is corresponding to cos, same limit, 0 to 2 pi. Okay, it is showing this kind of figure. Okay, so this is the polar plots. Then bar plot, bar simply x comma y, bar is 1 to 10 and random values of 1 comma 10. It will show you bar charts of this one. So all the, so 1 to 10, and the random values will have, suppose here it is 1 to 0.3, here 2 comma 0.9, here 5 comma 0.9, and what are the bars available here, corresponding values, it will show you in the form of bar. Okay, then quiver for this purpose we will just required mesh grid. So we just created the mesh grid of 1 to 10 in x and y, and saved it, and just type quiver. Okay, so it will show you the arrows. For this is the, as I already shown in the that figure, that these are the specified figures. Okay, these are not generally used. Okay, this can also be, then somewhat this is it is different from the bars. It will show you 1 to 10. Okay, the in this 1, 1, 2, 3, 4, minus 1. Click on this one to show you. These are the stairs. So staircase, or you can see it is different bar plot. Okay. Next one is fill. Fill will fill the. So you can see the limit. Let's say fill 0 to 1, and at 0.5 it will fill. So you can see at the 0.5. This is the 0.5. Okay. It is filling 0 to 1, and in between 0.5. R is showing the color of this one. So we can change the color. If you type over here K, so different black color will be there. Okay. If you type over here G, the color will change to green. Okay. Like that you can change this figures according to your needs. So these are some specified specialized plotting functions. These are very helpful in the plotting or showing some data representation function. Okay. So doc spec graph for complete list what available in specified graphs and plotting function available over here. Now how to make code efficient. So now till now we have covered this functions, flow control, line plots, and 3D plot, surface plot. Okay, image SC plot. Okay, some specialized plots. Now how we can efficient our code. Okay, because code are very lengthy. So for this person purpose, just find is very important function. Return indicates a non-zero. Sorry, non-zero values can simply code and help avoid loops. Okay, so it is possible to simplify the code also and avoid the use of loops. Avoid the use of loops. Okay, so it contains the indices at which x and y values are between 0.4 to 0.6. Okay, so if we are using 0, 1 to 100 values, and if we need only 0.4 to 0.6 value, so just use this one only. Okay, so x is greater than sorry, x greater than 0.4 and less than 0.6, we will specify this one in between the in our code. Okay, return a vector with 1 where true or false. Okay, so it combines the two vectors using logical write this code. Okay, so being more clever, just what I want. So this is written for the length of any method x. Okay, so you have to initialize this variable count and write n equal to 1 to length, then it will count the length of this matrix which you are assigning over here. Okay, but the count length find x is greater than 0 is the and find time will be 0.4. Okay, and for up to 100 to 1 lakh it will be 0 time, but for if you are using any loop it will take some time because it will read some data and it will execute data and it will give you some output. Okay, so find the time and optimize your time. So you can see for the 10,000 data points also the we can use it cleverly. Okay, between 1.5 to 0.4, this is the time we can say between this operation. Okay, uh, vectorization is preferred to avoid the loops. Okay, so vectorization code is more efficient for MATLAB. Use indexing and matrix operations to avoid loop. For instance, to add every two consecutive terms. Okay, like this. For instance, for a loop you are using if loop, it is using some time. Okay, it is very slow and complicated thing. Okay, or if you are using rand 1, 2, it is the efficient and clean and can also be used by CONB. Okay, so different commands are available in MATLAB to minimize the time. Okay, pre-allocation also one of the important. Avoid variables growing inside a loop. Unnecessary variables sometimes created, so we can remove these variables. And reallocation of memory is very time consuming. Pre-allocation the required memory of initializing the array to the default value. Okay, these are some examples of pre-allocations. Okay, now next one is debugging. How we can debug the code. Okay, for this one we can use the display. Okay, if you type this display starting loop, this display loop is over, so it will share our time, and the display we can use, or we can use this in between time between the starting loop and loop is over. In between, we can do some another work. Okay, so if the display shows the if display is in our mind, so we can save our time also. It is also helpful to show variable values. Okay, loop iteration, number strings, etc. Okay, so this also we can be used. Okay, so we can, when we are running any code, suppose the code is very lengthy, 100 lines or 500 lines. If I want to block the code or break the code, so we can use this kind of symbols available over here. Okay, so this breakpoints we can use. Okay, up to fifth line we want to know if the code length is very lengthy, 100 lines or 500 lines. I want to know up to the fifth line, so I will put a block over here, or it will call as toggle breakpoint. Okay, so one more point will be there. Clear all breakpoints, will clear all the breakpoints when we rectify all the problems. Okay, so at every step, at fifth point, 10th point, 50th point, at each and every step, you can see you can add all the breakpoints. Okay, and up to which limit or up to which length you want to execute your program is also possible in MATLAB. Okay, so click on the next line and numbers in M file. Each red dot that appear is a breakpoint. These are the breakpoints. And run the program. It is to run the program. Okay, the program pauses when it reaches to the breakpoint. When it will reach to the breakpoint, every time it will be paused. Use the command window to throw variable. Use the debugging button to control debugger. Okay. Now perform measures. Okay, so we can put these measures to know the time also. Okay, it can be useful to know how long your code take to run. Okay, if we put suppose if we put tick means the time will start at this point. Okay, at the end point you will write TOC. Okay, okay, a equal to TOC, b equal to TOC means at a point, suppose this is 5-line code is there, we are putting tick over here, a equal to TOC over here, it will show the time between these 2 points. Okay, so number of TOC are possible, can have multiple TOC per tick. Okay, so this will be TOC1, TOC2, and number of TOC can be used at one time. So this is very helpful for when we are making longer code. Okay, tick and stop. So for examples, sparse time, we are using this A zeros, B sparses. These are some commands. You can check this. Okay, and also you can check this tick tock. Okay, for slow and faster. Okay, if system is sparse, can lead to large memory and time saving. So this is the first this part of this lecture is completed. Now I'm moving ahead to the second part. Okay, in which we will see some these. So in this one what we completed plotting. After that loops, functions, flow control, line plots, image and surface plot, efficient code, and debugging. Okay. In this, we will see some linear algebra, polynomials, and some optimization, differentiation, and integration of equations. Okay. So as in the last class also, I discussed about this linear equations, how to solve the linear equations. Suppose we have three equations and three unknowns. So, okay, so what we have to do, simply we have to write, we have to make a matrix, A matrix, B matrix. Okay, so A matrix will be the coefficient which are available on the left hand side of the equations. Okay, so you can see the coefficient of this one. Okay, in A matrix we are putting, then 2, then -3. Okay, then for the second line we have -3, -1, and 1. And for last time we have 1, -1, and 1. Okay, for B matrix we have 5, -8, and 0. 5, -8, and 0. So simply, if you want to know the values of x, okay, we want to know the values of x, y, z, we'll simply put x equal to a backslash. Okay, so keep in mind, this is slash, not slash, this is black set. Okay, so from this equation you can see ax equal to b, so x equal to b upon a, but here it is a upon b, but it is black slash, so it will equal to this b upon a only. Okay, so it can be done by a slash b also, so sorry, b slash a also, but here we are using a backslash b. Okay, so it will return the values of x comma y comma z. Okay, the backslash will work with square and rectangular systems only. Okay, so this will keep in mind that it will work with square and rectangular systems only. Okay, this gives the least square solution for rectangular systems. Solution depend on whether the system is over or under determined. Okay, so again we can see for some systems work on linear algebra. Okay, for the system one we have, suppose x plus 4y equal to 34 and minus 3x plus y equal to 2. Okay, so the two equations we have, so simply we will write A matrix 1, 4 and -3, 1. A matrix is 34 and 2. We can also find out the rank of the matrix, rank A. We can also find out by this way, inverse of A into V, or A x equal to A backslash B. Okay, so this is the second system. Okay, so this is the square system, this is the rectangular system, so it will work in both the system only. Okay, next for more linear algebra functions, matrix, for a given matrix we can calculate rank of the matrix. Just type, so these are very small commands, you can see with yourself only. Just to make a matrix, just write R equal to rank of the matrix, it will give you the rank of the matrix, the number of linearity independent row and columns. Calculate the determinant. Okay, if you want to know the determinant, just write DET and in bracket mat, so it will show you the determinant of this matrix. Okay, matrix must be square, matrix invertible if determinant non-zero. Okay, get the matrix inverse by this command only, inverse of matrix. Okay, if an equation is of the form A into AX into B, with A is a square matrix, then X equal to A upon B is mostly the same as X equal to inverse of A into B. Okay, get the condition number, just type con M. Okay, so it will give you the reciprocal of this one. Okay, if the condition number is large, when solving AX into B, a small error in B can be lead to be large errors. Okay, and matrix decomposition also possible. So eigen value can be find out, singular value decomposition, QR decomposition, LU decomposition, Cholesky decomposition. All the functions are possible in MATLAB. Okay, so these are the exercises which I will provide to you for to solve these polynomials. Okay, again, if I want to solve this higher order polynomials, okay, so how we will solve? Any function can be described as higher order polynomial. So one is shown over here, ax cube plus bx square plus cx plus d. So the first place will be p1, and this will be the coefficient, this will be p2, then p3 and p4. Okay. So in this case, you can see this polynomial x square minus 2. In this case, what is showing for 1 in this matrix P, 1 is the coefficient of this one. Okay. So x is not available. So 0 is showing over here. Then the last place it is showing the minus 2. For the second one, only 2x cube is there. So 2 is showing. Okay. So for x square, 0 is there. For x, 0 is there. And for the constant, 0 is there. Okay. So like this, we can make a vector of the coefficient. Okay. Okay. After that, making this one, these polynomial, we can find out the roots. Okay. If roots are available, then also we can get the polynomials, which I am showing with example. Suppose we are making a matrix. Okay. So we are making a P matrix. Yes, just type clear in CLC. We are making a P matrix which have values -2, 1, 3, 3, and 0. Okay, this is P matrix. Now I want this first function. I want to know the roots of the polynomials. So I will just write r equal to roots and it capital P. Okay, so it will give me the roots of this polynomial. Okay, so r equal to the roots of this polynomial. Again, I want the polynomial from these roots. How will I will get pp equal to poly, pp equal to poly, and it is saved in r. Okay, saved in r. So these are the values of this coefficient of this polynomial are available over here. Okay, so from the roots also you will get the polynomial, and from the polynomial you will get the roots. Okay, to evaluate a polynomial at a point polyval p comma x0, x is singular value, y is singular value, is it also polyval? Okay, to evaluate a polynomial at many points. Okay, it is for single point, this is for many points. Okay, polynomial fitting also possible. So for this purpose, you have to write some extra things in this plot command. Okay, so p2 is the polyfit x comma 2. It will fit between x comma 2. Okay, x is a vector, y is a vector. In between 2 will be the least square sense. Find the best least square sense second order polynomial that fits between the points 1 comma 0, 0 comma -1, and 2 comma 3. For more information, you can go to the polyfit for the more information. You can change the marker size, you can change the marker phase, and all the things or which already discussed in the previous session. Okay, so these are the exercise I will share at the end of this session. Then optimization also possible in the MATLAB. Okay, for this purpose, inbuilt function m1 is also there. Okay, make a separate function file. Okay, for the optimization purpose, and just execute like what is available over here. I am showing you. Okay, so simply minimization of a function over a bounded interval means this is the boundation of the interval. So you have to write like this: x equal to m min b and d. Here will be your function, whatever it is. Okay, and this will be the interval -2, -1 comma 2. So m1 takes a scalar input and return the scalar output. Okay, and m1 x will be the minimum of m1 for -1 to 2. Okay, then unconditional interval between the finds the local minimum of m1 starting at point 0.5. Okay, so for this function you can call mfin b and d, and for minimum set you can call fmin search. Okay, for maximizing gx by minimizing fx equal to minus gx. Okay, solution may be local. Okay, so this is your we can see the function over here. Okay, this will be the input, and this is function which we want to evaluate. Okay, you can see that you can make a anonymous function of your own. Okay, can also store the function handle. Okay, function equal to @x cos expression of x. So these function can be made according to your need. Okay, these are some anonymous functions. So optimization toolbox also available. Okay, if you are familiar with optimization methods, use the optimization toolbox. Okay, use larger, more structured optimization problems. Okay, simple functions, lin program, quad program, fin, fmin, con are available in the toolbox. So this is just for the information to you also, and these are the exercises you can do with the optimization toolbox. Okay.
Fine.
Then regression of numerical issues. Okay, this is just an approximation. So simple examples are there, like sin pi, sin 2 pi, sin 10 to 10 e to power and 10 to power 16 into pi. Okay, both sin and pi are approximation. So you can use this with the help of this approximation also. A word question also there. Okay, MATLAB knows no fear. Give it a function, if it optimization differentiate integrates, that's great. Okay, but not magic. Beware of over testing the solutions. Okay, you will get an answer, but it may not be what you want. Okay, so symbolic math toolbox also there, can take the help of this one also. Next, we are moving ahead to differentiation and integration. Okay, so for this purpose, you can use the function diff. Okay, the command diff for the differentiation. Okay, so here we are showing d simple x 0 to 0.01 with a step. Okay, up to 2 pi, and y will be the function of x, so it will be sin x. So dy dx, so differentiation, what you will do, diff y and diff x. So what is the meaning of diff y? It will differentiate between the y vector. Okay, suppose there is a matrix available over here, 1 3 5 and 4 4 8 6. Okay, so I'm showing you with the help of this diff, what diff will do. We can see over here, it is possible with three ways. Diff x. Okay, it will be a vector, and it will differentiate it between n x comma n. Some n is the rows are given. Okay, then dimension also given, to which dimension, 2 dimension or 3 dimension you have to remove, that is also possible. Okay, so what diff is doing, you can see over here, x equal to a vector over given over here, y is the output. Diff, if you are giving diff x, what is doing, this is 1 minus 1, differentiate 1 minus 1 0, 2 minus 1 1, 3 minus 2 1, 5 minus 3 2, 8 minus 5 3, 30 minus 8 5, and 21 minus 13 is it is the y matrix. Okay, now that y has one fewer element than x, because it is differentiated. Okay, suppose there are eight elements are available here, but you can see this is only 1 cross 7 matrix. Okay, again you can see diff x. Okay, so it will reduce, you can see this is the 3 by 3 matrix, but it is over, it is here 2 by 3 only. But why it is like that? Because it is doing like that, 5 minus 1 4, 5 minus 1 4, 5 minus 1 4. Okay, and for the next one it is doing 25 minus 5 20, 25 minus 5 20, and 25 minus 5 20. Okay, so like this it is differentiating. Okay, so like it is differentiating. So it is also possible in numerical differentiation. Can also operate on matrix dm equal to diff matrix 1 comma 2, like I shown you. Okay, this can be used over here. Okay, so you can use a 2D gradient also, gradient matrix. Okay, these are some specialized commands available for differentiation. For integration, you can use some specified mathematical functions like Simpson quadrature trapezoid rule. Okay, so for that purpose, you have to just write quad. For Simpson quadrature, you have to write quad. You have to write function over here, and the limits means constant 0 to 10. Okay, so q is the integral of the function m1, which is available over here from 0 to 10, integration between the limit. Okay, so this is showing q2 quad at the this. So in this, what is showing integration of sin x into x from 0 to 5 in this limit. Okay, so this is according to Simpson quadrature as an input function. Now you are using trapezoid rule input as a vector. So what you will use for any function z equal to 0 to pi with the increment of 0.01. Okay, so how we will write trapezoid x comma sin x. So here x also, sin x also a function of x. So z is the integral of sin x from 0 to 5. Okay, so this is for square root of e to the power x upon x. Okay, z2 will be the integral of e to the power x upon under root e to the power x upon x from 0 to 5. Okay, so these are some predefined functions which are used for numerical integration. Okay, for differential equation, how we will do? Okay, so for this purpose, we will use some ODE solver. Okay, so ODE solver are different type. Some for lower order, some for higher order. So generally higher order ODE 45. Okay, this is the Runge method solver, which is generally used for the solve the polynomial of the equation for differentiation. That is ODE 45 for high accuracy and reasonable speed, most commonly used. Okay, so here are three types: ODE 23, ODE 45, and ODE 15s. Generally, ODE 45 will be preferred. Okay. So how we will call the functions in over here? So just we will write OD 45. OD is the integrator. So OD is the OD function. What function you want to differentiate? Okay, this is the time range, and this is the initial conditions or predefined condition. Okay, what input it needs? OD function name it requires. Okay, so we can make a function. Okay, which we can call over here. This function should take input in t comma y. Okay, so this will be t comma y and return dy by dt. Time interval, two element vector with initial and final time. Initial conditions, column vector with an initial condition for each ODE. This is the first input to the ODE function. Okay, make sure all inputs in the same variable are in order. Okay, output what you will get is the time points. Okay, t contains the time points and y contains the corresponding value of variables. Okay, here t is the output, contains the time points, and y is the corresponding value of the variables. So this side you have inputs, and this side you have output. This will be your OD function, and this will be your integrator OT 45 or whatever your 923 or 15f over here. Okay, so this is the standard syntax for OD solver. Okay, so you can see over here OD function dy by dt. Okay, these are the two equations: dA upon dt equal to minus 10a plus 15b. Okay, so we are calling this as CHEM function t comma y. Okay, so dy by dt1 will give you these values. Okay, and dy by dt will give you these values. Okay, and it will give you the output. Okay, so how we can read the result with the help of plot. Also we can see the result. Okay, plot t comma y, all rows first column. Okay, like already shown to you, plotting already shown to you. So to see the output. Okay, so these you can type after writing your code. So how we can see your output with the help of this plotting commands. Okay. and many more higher order equations are available over here. I'm not discussing all the things. Okay, so plotting already done. Plotting, this is showing just the output, how we can see the output of this differential equations. Okay, these are the exercise I will share with you later. So this is the second part of this session is completed, and one more, there is that is polyder. Okay, so this polynomial equation, apart from this, I have shown you, apart from this ODE 45, this polynomial equation also be solved by this polyder. Okay, so you can see, over here, the use polyder to obtain the derivatives. The derivatives of this polynomial px equal to x cube minus 2x minus 5. Okay, the resulting polynomial, the derivative will be, what will be, 3x square. Okay, dy by dx with respect to px, this function px, we are derivating this one, so we will get 3x square minus 2. Okay, so with the help of this polyder, how we can write, we will just write the coefficient what are available over here. Okay, like we are solving for the x equal to b by a, we will just write the coefficient. So for this one, 1 will be here, then x square is not available, so 0 will be here, coefficient, minus 2 will be here, then minus 5 will be here. Okay, so for, we will create just matrix of this coefficient p equal to 1, 0, minus 2 and 5, and just q equal to polyder p. We will just write polyder p. It will give you the result of this polynomial equation. Okay, and again, if I want to integrate, so this is the differentiation. So differentiation, what you are getting, 3, 0, minus 2, 3, x is not available, 0 and minus 2. Okay, so this is the simple differentiation of this polynomial equation. So you can see the order of this equation is reduced to, let's say here it is showing 4 coefficient, here it is showing only 3 coefficient. Okay, so you can see, so I am showing you again for this integration purpose. Okay, so for differentiation we use polyder, for differentiation integration we use polyint. Okay, so this polynomial ex equal to 4x cube minus 3x square plus 1, so the resulting polynomial after the integration will be x to the power 4 minus x cube plus x. Okay, this will be our result after the integration. How we can solve with the help of this command only? So we will write just coefficient 4 minus 3, 0 and 1. Okay, and q will be our output after integration. So polyint p, we will just write polyint p. Okay, and after it we will get this coefficient. So this will be our output after the integration. Okay, so this will be our x to the power 4, this one, and this is for minus 1x cube, then x square is not there, then 1x, then 0. So this will be our output after integration. Suppose there are two polynomials together, we want to differentiate, how we will do. Okay, so for that purpose, polynomials also compute derivatives of product or quotient of two polynomials. For example, create two vectors. Okay, so two equations are there, two vectors are there, so we will create two vectors. Ax equal to x square plus 3x plus 5. So a will be 1, 3, 5, 1, 3, 5, 1 matrix. 2, 4 and 6 will be the second matrix. Okay, so how to calculate the differentiation of this matrix? Okay, so by calling polyder with single output argument. So C will be the output, polyder A comma B. Okay, polyder A comma B. So A matrix will be there, B matrix will be there. So dy by dx, Ax into Bx will be 8 into, the matrix will be 8, 30, 56 and 38. Okay, now same we can do for the two output, calling polyder with two output arguments, the resulting polynomial will be like this. Okay, so we can just write q comma d. Okay, two output for two or output argument, we just write q comma d provider a comma b. Okay, so I will share these sheets with you, so you can also practice this how to find integration differentiation of the polynomial, how to differentiate these. Okay, and some optimization problems, ODE and integrations. Okay, so differentiation of any vectors or differentiation of two vectors with multiple dimensions. Okay, and plotting commands, functions, flow control, line plots, image and surface plots, plot 3D plots, efficient, how to we can make an efficient code, how we can do the debugging. Okay, so this is all from me for today's session. Tomorrow we will discuss some laboratories problems or some experimental problems which generally we use for the BTech students, like how to solve a shear force bending moment problem, or some spring damping problem, or one and the session for the Simulink also, the basics of how we can design a PID controller. Okay, so if any question is there, so anyone can ask. Anyone is there? Hello.
Hello, sir.
Hello, sir.
Sir, any manual is there to learn entire for this concept integration?
What, sir? What, sir?
Sir, any manual is available to learn the entire complete as MATLAB software?
Yes, sir. If you want from me, I will share with you. Otherwise, if you search on search in Google, it will many materials is available which are well designed. Okay, from basics to how to start a MATLAB. Okay,
Yes, sir.
how to create a matrix, how to multiply what arithmetic operations I showed yesterday is all are available in one book also. Okay, if you need anything, I will share with you. Okay.
Thank you, sir. Thank you, sir.
Okay.
Sir, if I have any doubts, I will call you, sir.
Okay, sir. Please reach me out. If you my number is there in WhatsApp. Okay.
Okay,
You
sir.
can reach.
Okay, sir.
Thank you, sir.
Thank you, sir.
Okay. Thank you, Sheshaya Durga, sir. Anyone is there? You want to any doubt or any questions? Okay. Okay. So I am ending this session over here. Tomorrow we will meet at the same time at 10 a.m.
Sir, one more doubt, sir.
Okay.
Sir, actually, we are drawing all the plots, figures, everything was in origin plot, na?
Yes, sir.
Origin.
Sir, Origin is different software, sir.
Origin is different software, but you can draw same plots by using this MATLAB.
Yes, sir. Sir, actually, in MATLAB programming is also possible. Na? As you can see, this with single command, I have shown you this polar also.
Yes,
so this is giving you immediate plot. Okay,
yes,
you are able to view this matrix over here. What command we are giving over here. Okay, and again immediately you are able to see this output over here. But for Origin, what you do, sir, we will take some data from here. Okay, the matrix we will need to take as input from here and copy there, and we have to plot there. So that is a lengthy process. Okay? There is no doubt, sir. Origin also a very good software for plotting purpose. Because MATLAB also possible. For immediate result means if you want to see your result immediately, it is very good. Okay? And if you use for a publication purpose also, it's very helpful. As you can see, sir, simple plots I drawn. Okay.
yes, sir.
So these all are possible in Excel and Origin. What you are saying, sir, all are possible.
Sir, suppose for example I conducted tensile test,
Uh-huh.
but if you generate so much data, a lot of data,
Yes, sir.
x and y axis, like stress and strain.
Mm-hmm.
But I have to write a code for in MATLAB.
For what purpose, sir?
For suppose I have to generate sustain curve by using lot of input data. Is it possible in MATLAB?
Why not, sir? If you have input for stress assistant curve, if you have stress corresponding to strain, it will be possible. Okay.
Okay, sir.
If you want to know with this one, just provide me the data. I will show you how to process. It is possible, sir.
Okay, sir.
Okay. Thank you so much, sir, for discussion. Anyone is there? Okay. Thank you all for today's session. Okay. So we will meet tomorrow at the same time at 10 a.m. morning. Thank you so much.